Hi, and welcome to my session, Optimizing AI Applications for Production with Observability. My name is 𝗦𝗲𝗀𝗀𝗀𝗀, and in this session, we're going to look at observability, some of the concepts behind it, and a technology called OpenTelemetry. I'm going to explain what observability means, what it means in the context of an application, and then some considerations for using observability in production. We're also going to look at some examples of where observability and OpenTelemetry are really useful with AI applications. In particular, when you deploy those AI applications into production and you need help to triage performance issues or bugs or any of the challenges you might get in a production environment. I'm going to give you some demos of each of these working with different samples. And then lastly, we're going to cover off with some summary and resources. The technology shown to you today, the demos will be Python and also some .NET examples, but the technology itself is agnostic, so it would apply to any other language or any other platform. Okay, so first of all, what is observability? Now, many of you may be familiar with the concept of monitoring and to monitor a system. Observability really goes beyond that. And observability is designed to get a better understanding of an application by observing its outputs and then instrumenting its inner workings. So there's two really important concepts here. One is to look at the different outputs of a system, and the second thing is to look at instrumentation of the inner workings. The more information that we can gather, the more that can help us to understand a system, its traits, and to help us when things can go wrong. As an example, cars have a lot of instrumentation. Now, there's the stuff which is more obvious on the dashboard, like the speed, the engine temperature, and you also have lights that can come up to say that maybe your oil is low or your tire pressures are low. These are warning lights. But there's also additional telemetry that's built into the car that can be seen by a mechanic. So if you take your car into the garage and say, I've had issues with the car's performance or when I'm changing gear, then a mechanic can look at the telemetry data and better understand what's happening with the engine without having to reproduce that themselves. This is really similar to what it's like working with customers and working with users in your application. So why would you have observable applications in the first place? One of the really strong points here is the benefit of hindsight. And in the car analogy, the mechanic can better understand what's happened with the engine, what's happened with the car by looking at recorded telemetry data in the car. Whereas with your application, you as a developer can look at the information in the telemetry, and as you've observed it, if a user comes to you and says there was an issue, now not every issue has an error. Sometimes an issue could be that the app was running slowly. In an AI application, it could be that maybe the app was giving an incorrect answer or the types of responses were different. So you need the ability to go and find the information, to understand the context, and then to make decisions as to how it can be fixed in future. Observable applications also try and simplify complexity. So as far as the user is concerned, they have an interface, they interact with that interface, and then they get something back. But behind the scenes, that system can be many different services, it could be microservices, different components. You could be calling APIs, you could have a database. There's a lot of components involved in a modern application. And using observability, and in particular with OpenTelemetry, you can see a single view across all of that information. And then something else you can do with observable applications is you can identify trends. So let's say that performance has slowly been degrading for certain types of question in your AI application. Does that correlate with the last release you did? Does it correlate with a patch or a change to the database server? What is the trend in user patterns? How is adoption impacting performance? These are the sorts of things you can get once you've got the instrumentation in place in your architecture. OpenTelemetry is a modern open standard for observability, and it's a framework that you can use for any application. You can trace end-to-end from the front end to the back end in a distributed architecture using OpenTelemetry across the whole stack. This is possible because it has language SDKs for all modern languages and platforms. such as C++, C#, Go, Java, JavaScript, Python, Rust, and lots more, there's also an ecosystem of libraries for instrumentation of most popular frameworks, tools, and database infrastructure. There's also extensions and libraries to export the data into SIEMs or operational tools. OpenTelemetry is governed by the Cloud Native Computing Foundation. It includes a set of open standards that have been adopted by lots of different software vendors and instrumentation libraries. There's also a standard protocol called OTLP, which is for communication between the data collector service and operational software, such as dashboarding and monitoring tools. So the architecture of OpenTelemetry is that you have, first of all, your application, your code. And then on top of that, you have instrumentation from OpenTelemetry. So this can be either automated instrumentation, where OpenTelemetry detects what is in your application, which tools are you using, which frameworks. You can specify or configure specific instrumentation libraries. You can find each of those instrumentation libraries on the OpenTelemetry site, or you can write your own custom instrumentation using the SDK. So if your system is proprietary or you want to measure or monitor something very specific, you can design that using the SDK and customize that. The instrumentation will emit three things: traces, metrics, and logs. And I'll explain in a second what each of those mean. It gives them to a collector service. The collector service runs in process, so it's part of your application component. If it's a front end, then it has to run in a process, either a service worker or on a server-based service. If you're working on a backend system, such as C#, .NET, or Python in the web app, then the collector runs in a separate thread or a separate process. It keeps all of the instrumented data locally, and then it forwards it on to an exporter. The exporter is where it collects the telemetry data and then gives it to your operational tools. This could be things like monitoring tools or dashboards. Often you'd consume those as a user interface, or you'd consume them as an API or a log service. So OpenTelemetry really gives you a vendor agnostic way of instrumenting your application and then picking which tools you want to monitor it and get insights into the app. So the three things you get from instrumentation are traces, metrics, and logs. Traces are really the most core concept with OpenTelemetry. It represents a unit of work, and that is called a span. So for a trace, you would have one or many spans. Each span can have attributes, which are information or additional properties of what was happening for that particular call. Spans are created by instrumentation libraries or manually via the SDK, and then nested. So for example, if you made a server call, that would be a span. If that server call ran a SQL query, that SQL query itself could also be a span that belongs to the server call. So you can see that as a trace from the front end all the way to the back end about all of the things which happened, all of the services which are called, and any attributes that are involved. Spans have got kinds, which are client server, internal, producer, or consumer. Most of the instrumentation libraries configure this for you, so you don't need to know the details. A lot of the libraries are really just plug and play. So if you know what you're using, which front-end framework, which back-end framework, and then you've dropped in the instrumentation libraries, it will just start instrumenting that automatically. Metrics are another concept. They are measurements that are captured at runtime. So in the car analogy, we have things like our speed or our engine temperature. Those are not necessarily part of a span. They're just live attributes of the system, and they're created by meters. Some instrumentation libraries do emit metrics. Not many of them do at the moment. So often you have to write them yourself using the SDK, or you have to configure that specifically with the instrumentation library. Meters can be aggregate or live. So it could be the total number of calls, or it could be live as in the remaining number of API calls left within a trigger. And then finally, you've got logs. So this is designed to drop into existing logging infrastructure. So logs are really a timestamped text record, and they can be structured or unstructured. So you can have unstructured logs, which are just text records, or structured logs where you've got additional data or attributes you want to keep with the log. Often logs are associated with a span or a trace, but they don't necessarily have to be. So you can have OpenTelemetry to replace your logging solution, to replace any tracing that you might have, and also to do system metrics. Log exporters can plug into existing logging infrastructure. So for example, in the case of C#.NET, you can plug that in and all of your logs would automatically go to OpenTelemetry. In Python, it plugs in with the logging module. So any times or any calls to logging would then get forwarded on to OpenTelemetry. In terms of support in AI applications often include one or many SDKs to talk to different AI systems, or to work with models locally, or to work with different vector databases, for example. So an AI application normally consists of multiple frameworks or multiple tools. So it's important to understand with OpenTelemetry which ones are supported and what information you're likely to get out of the system. For something which is all-encompassing like semantic kernel for .NET, it supports traces, metrics, and logs. If you're calling Azure OpenAI or OpenAI in the public sense, and you're using the SDK client, either for Python or for JavaScript, traces are fully supported, and then you can customize that with metrics, and I'll show you an example of that later. If you're using any of the Azure SDKs, for any of the languages, Python, JavaScript, .NET, and also for Java, then OpenTelemetry will emit traces automatically, and it will also support any existing logging that you have. And then finally, if you're experimenting with PromptFlow supports OpenTelemetry out of the box, and that works by emitting traces for your flows, and it converts your flows into traces. And then if you're using logging, also you get that information. If you're using third-party libraries as well, then there's great support for OpenTelemetry. LangChain with instrumentation supports traces, metrics, and logs. With Elasticsearch and Elastic Tools, you can also get traces. They have full support for OpenTelemetry, as does Redis, either as a caching store or as a vector store. And if you're using something like llama-index as well, then it also supports OpenTelemetry for both tracing and logs. If you're using llama-index, it also supports OpenTelemetry for tracing and logs. So part of .NET 8 is the Aspire technology, and in the Aspire technology is something called the Aspire dashboard. The Aspire dashboard is a standalone OpenTelemetry dashboard designed for local testing and development. This is a great option if you're using OpenTelemetry in your application, whether it's .NET or Python or any other language, and you want to get OpenTelemetry support and have a glance into logs, traces, and metrics in a local development environment. It has a built-in dashboard. You can run it from a single Docker container, and it supports OpenTelemetry via the OTLP exporter. This is perfect for when you're doing local development and testing, because you can spin it up on a single container. You can look at the logs, you can inspect the traces, look at the attributes, do all of your testing and debugging, and then when you're finished, you just turn it off and you free up all your space again. So let's have a look at a demo of .NET Aspire dashboard running with a Python application. So in this demo, I'm going to show you the .NET Aspire dashboard running as a Docker container locally on my development machine, and then connecting an application that I've been working on in Python that uses OpenTelemetry instrumentation to export that instrumentation into the Aspire dashboard so that I can see what's happening when I'm testing it on my local environment. So to do that, I'm going to do Docker run. I'm going to map a couple of ports. One is the web interface, which is on 18889, and then also the OTLP endpoint, which is on 18888. Call that the Aspire dashboard, and I'm going to configure that with a simple API key, which I've just generated as this string here, and I'm going to run the Aspire dashboard version 8 preview. So when I run that Docker environment, it's going to spin that up and it's going to print out to the dashboard on the console this URL here. So then once that's connected, I'm connected to the web server locally of the .NET Aspire UI. And I've got structured logs, traces, and metrics. There's nothing to see at the moment because my app isn't running. So I've just started my application up. So that is running completely locally, but it is connecting to external services to do things like AI completion. So now that my app is up and running, I can use some of the pre-configured questions to interact with it, and that's going to kick off the traces. So in the Aspire dashboard, I can see a live view of what's happening, all of the server requests that went in on the web server, and I can click on one of those and see all of the trace data in this view. So this is a full end-to-end view of everything that happened in my application, from the call on the front end made by the browser to make the chat request. I can click on that and I can see all the attributes such as the span ID, what the host was, where it's running, what the post parameters were, and then anything which happens in my application on the back end, which is things like an Azure OpenAI chat completions call. I can click on that chat completions request and I can see what was the context, which prompts were used, which parameters were used in the LLM, things like that. So I can also see things like tool calls. So all of those attributes are kept here and I can see how long that took. So in terms of the lifespan of that request response, this is a local environment, so it's not going to be very fast, but that took 11 seconds, mostly just to warm up. But I can see that that took 7 seconds for the chat completion. I can see that the embeddings call here took 921 milliseconds, and I can click on that embeddings call and I can see which model configuration it was, how many tokens it consumed, things like that. So all of this is in the Aspire trace view. I can also see structured logs, and in Python, those are anything which is set to the log provider. So in metrics, if you pick on the resource, and then I've configured the remaining requests and the remaining tokens, and also on the HTTP server, some additional numbers that come through. And you can either see that as a graph, as it goes up and down, or as a table. The default view is the last 5 minutes, but if you want to see something longer than that, you can configure in this drop down here. So I find that the remaining requests and remaining tokens left back on the model is a really helpful metric when you're testing. So you can see what is consuming tokens, what are the response times, and what does that look like. Also, if there are any errors, so for example, this particular call had an issue, I can see what the error was, what caused the call, and any exception details, and a full stack trace in there as well. Now, .NET Aspire is perfect for local development and testing, but in a production environment, we want to persist our traces and our logs and our metrics as historical data that we can look back on. This is where Azure Monitor is a great option. Azure Monitor, using App Insights, supports OpenTelemetry and can capture data that has been instrumented from OpenTelemetry in any platform. You can get this in a form of an end-to-end transaction in Azure Monitor, and you can click on a span, and then you can inspect all of the attributes and look at the properties in the Azure Monitor window. The UI is built in. It supports OpenTelemetry via the Azure Monitor Exporter, which is a standalone module that you install into your OpenTelemetry environment. And it's delivered as a service in Microsoft Azure. Azure Monitor is ideal for production workloads where you want to see historical data and you want to make sure that it's captured securely and archived. Let's see a demo of that working in the same application. So next I'm going to show you that same application, but this time instead of running it locally, I've deployed it into Azure, into App Service. The code is the same, but the application is configured so that if it detects that it has an environment variable with application insights, it will export all of the OpenTelemetry data to application insights using Azure Monitor. So the same experience that I had before where I was using the Aspire dashboard, instead of that, now it's sending all that information to application insights in Azure Monitor. So when I go to application insights, I can go to application map, and then I can see which services it's calling in the backend. If I want to focus on something in particular, for example, the OpenAI calls, I can click on that in the graph, and then I can see which particular calls are being made and how long each of those is taking. So I can see the difference between my chat completions and my embedding requests. And then if I want to investigate the slowest calls in particular, I can click on that instance. On the performance tab, you'll see all of the operations that have happened over the last time period. So I've sent a couple of requests. Let's send another one just to get a bit more data in the demo. And as that's coming through, I can pick on the backend calls. So these are the static assets, but this one in particular I'm interested in, which is the chat request. I can see one of those, and that's the one that I did as a test. If I drill into that sample using this button here, and then click on a particular instance, so the one I made a minute ago, a chat request via the web app, then I can see the full end-to-end transaction. So similar to what I saw with the Aspire dashboard, I can get that in Azure Monitor, and I can see things like the chat completion. I can see information about the chat completion here, which model it was, what parameters I had, what were the prompts, what were the system prompts, what were the user prompts, and then also what information did I get back. I've also cataloged things like the search request to AI search in here. So for this timeline, for this particular request, I can see what time was taken up doing the chat completions, what time was taken up doing embeddings, doing the search on the back end, and then streaming the data back to the user. Okay, so we've shown you a couple of technologies for looking at dashboards. Now let's look into something a bit more concrete. So RAG, or Retrieval Augmented Generation, is a technology where you combine a chat model, an LLM, with some sort of retrieval mechanism. And we have a sample that we've been working on for the last year that combines AI search with retrieval on a vector store, and is really a way of querying your data, looking at PDFs. I've picked this because I think it's a good example of an AI application where observability and distributed tracing is actually really helpful to understand what's happening in the system, and when things have gone wrong in the system, to recreate that or reproduce it, and to better understand what caused that issue and what you can do to stop it from happening again. So a summary of the system is that a user would ask a question in the chat app. It does a document search using AI search. It would return some results, and it gives those results to a large language model. And it says to the large language model, here was the question, here's the answers I found in the search index. Can you represent that back as a plain text answer to the user? So that is our sort of high level architecture of the application. Now, when you're looking at having observability in a RAG application, you need to think about a few different components, what you want to observe. So the user interacts with the interface. That could be a web interface, a mobile interface, or an API. So you've got the front-end component first. That could be in any stack. It could be .NET, Python, JavaScript, or even a combination of those. So the first thing you want to do is kind of capture and identify the user, and then to assign that request a unique identifier. So if they asked a question on the front end and the front end was in React, for example, and that called an API in Python, and then that spoke to the LLM and also to the search query, you want to make sure those things are connected, so that if the user gets an error in the front end in React and it says, sorry, something went wrong, you know what the request was, when it happened, and you can see and associate the different backend calls with that request that happened on the front end. So on the front end, that's where you want to capture a user request as a span, and all the instrumentation libraries that I've mentioned here, Blazor, Flask, FastAPI, React View, will do this automatically. So they'll assign a span and a trace ID to any tracing. If you have something which isn't supported, you would need to do this by hand, but all major frameworks are supported on the front end. So it would assign a trace on the front end, and then you have a retriever. So in RAG, often this is a database or it's a search system that understands AI queries. So in the case of Azure AI Search or Azure Cosmos DB, those are API calls that you're making. For Postgres, Quadrant or Pinecone, they're more sort of similar to database calls that you're making. So each of those you need to think about, how do you instrument that call and what attributes do you want to keep? So the attributes could be, what was the query that we made? What were the results back? How many results did we have? What specific configuration did the user ask for? So if you allow the user to tweak how many answers they can have or which language they're asking the question in, if you add all those attributes, you can see if there's been an issue, how do you reproduce that and how do you better understand it? And then next, when you're communicating with a model, with an LLM, the model can answer questions based on the query. So you give the retrieval output to the model, and then the model would then represent that back as text. You can just capture and instrument the API call to the model, which is fine. But there's also extra stuff that you probably want to instrument, including the metrics. So the metrics can be things like, how many tokens have we consumed currently? How many are remaining in a quota? How many tokens per minute are we using? So kind of trying to better understand the API usage and also how much of the LLM is being consumed. And then lastly, you've probably got either a custom code, which is connecting all of these things together, or you're using one of the sort of glue libraries that are designed specifically for AI, such as LangChain, Semantic Kernel, Llama Index, something like that. So this glue library is what's connecting the call in the front end to the retrieval to the LLM, and then chaining that back again. So ideally, you'd want to find one of the libraries which supports OpenTelemetry. All of the three that I've mentioned do, but that is via an external instrumentation library. And those chains and flows are emitted as traces. So all in all, if you capture all of this information and you set up OpenTelemetry with all of these components, when a user comes in and asks a question from your RAG app, you're going to get a full trace, all of the attributes, all of the information, and you can really understand what's happening behind the scenes. Okay, so let's look at some specifics for OpenTelemetry with a RAG application in AI. So the traces would be the retrieval calls, the API calls to the LLM, documented search lookup calls, and also any authentication. Each of those different components could possibly go wrong in different ways. So go wrong could be there was a system error, you got back an API error, or a search lookup could fail because it doesn't return any results, for example, or authentication could fail because somebody doesn't actually have permission or shouldn't have permission to do something. So each of those should be a trace, and you can connect them together with OpenTelemetry. In terms of metrics, you would want to capture and look at tokens in particular with AI, because the retrieval mechanism and also the models rely so heavily on tokens, and each of those has a quota on how many tokens you can use. So how many is used, how many is remaining, how much is each user using? Do you need to throttle particular users? And also, what are the response times back from the AI? So if a user starts to complain that the app is running slowly, for example, you can see what types of question they were asking, whether the slowdown was on the retrieval side or on the LLM side. And then also you can use text logging for the specific queries, any safety violations if you're using an LLM-based model that supports safety configurations, and then also what was the response back from the LLM. So if you do have questions or complaints from users about the quality of the responses, or you've got some concerns about the quality of the responses, then you have an archive as to what happened, what they asked, which retrieval mechanism it spoke to, and what the results were. So in summary, try and capture AI specific attributes on the traces. Definitely try and track token usage on the metrics, and then add the trace ID to log entries so you can see and associate anything that could happen in the archive. Now, to wrap things up, I'm going to show you how we can start to test our application a bit more, and then look at how OpenTelemetry is going to help us to understand some of the challenges. So I'm running a load test using the Locust framework, which is written in Python, but it can be used to load test any application. It's free and open source. And I'm running Locust on our chat app. And this load test will actually go and simulate a user and issue chat requests. And I'm running that against 10 users simultaneously. And I can see there's a couple of spikes here in the response time. So we had some really slow responses and another peak here. So I want to understand what happened in these particular instances. Also, I had a peak here where there were a few failures in the application. So I'd like to understand what caused that and where did those failures come from. So if I go back to application insights and then the application map and then refresh because this load test is running in the background, then I can see I've got a failure rate of 8% there, and I can click on that and I can see what were the failing requests by name. So it's saying I had 6 failures of the post chat, which is what I'd expect because that's what I was testing. And then it says I had a 500 error. So what I can do is I can see each of the instances here where it crashed. So there was an issue with the application. So that's 1, 2, 3, 4, 5, 6 where it happened, which is the ones I had in the graph here. So in the UI, I can click on each of those and I can see the full trace. And in the trace, I can see, okay, at what point did it fail? So where is that exception coming from and what caused it? And it's saying to me that there was a rate limit error. The rate limit was exceeded, try again in 2 seconds. And that is actually coming from this trace to this part of the code. So I can see it's in the approach, the chat approach, which is the code that talks to the LLM. And I can see some extra detail there. So that helps me because I can see, okay, that's where the error happened. But because I'm using OpenTelemetry, I've got all this extra data as well, such as, okay, did the initial chat request succeed? Did the embedding request succeed? And actually the error is on the second chat request in the application flow. So that helps me because I can see completely what's happened at every point in the chain and what's caused that issue. Now, that's not just with failures where there's an explicit error, but you can also look at, okay, for all of these calls to the AI, the LLM, then I can investigate performance. So I can look at what is the distribution of the response times between the chat requests and the embeddings requests. So embeddings are typically a lot faster to generate. So for the 69 embeddings requests that I had, here's the distribution of the response times back from the API. And then for the chat request, the distribution is between 230 milliseconds all the way up to 25. So what I can then do is to filter down for the long running ones and then drill into the specific samples where it had a very long response from the API. And I can click on those and see, okay, what were the parameters, what was the user, and what scenario it basically created that and where did that happen. And often it's because if you've hit a rate limit on a particular model, which often occurs if you're doing load testing or you haven't configured the model properly, then the subsequent request is then throttled. So that's where you get the slow response. So this is kind of where I can use all this instrumentation that I've gathered from the application. I've got it in App Insights, and I can drill into the detail and see not just specific errors, but also understand the performance criteria whilst I'm running a live load test. So for the 2 custom metrics that we configured as well, so that was the number of outstanding tokens against the model in Azure OpenAI and the number of outstanding requests against the rate limiting system. Those are the 2 metrics that we added to our code that don't normally come with the instrumentation, but they're really helpful to understand when you're doing load testing and when you're looking at production systems against Azure OpenAI in particular, because you have a certain number of tokens for each deployment of a model and a certain number of requests per second also that you can issue. So For the test that we were doing, we can click on the metrics drop down and we'll see OpenAI rate limit remaining requests and OpenAI rate limit remaining tokens as well. So if I add both of those to the graph, and then for the time span when we were running the test, then we can see which one was exhausted first. So here we've got the remaining tokens, which takes a sharp downward turn, and then we hit, I think, almost running out of tokens with our deployment whilst we're doing the load test. And then if you focus just on the number of outstanding requests that are able to be issued, that graph also gets really low. So we were really kind of hitting the rate limit when we were doing the load test, both with the number of tokens that we had configured and the number of requests that we were allowed to issue. You can also configure in the metrics, you can add other things such as some of the system metrics, the number of failed requests that are coming back from the server. So that will correspond with what we're getting in the failure logs. So you can kind of combine those and look into specific issues. Okay, cool. So that was a full end-to-end demo of OpenTelemetry with a RAG application. So just to recap, OpenTelemetry is a plugin solution. You don't need to re-architect your application. You can drop OpenTelemetry on top of an application. You can stick with the same stack you have now, the same language, the same libraries, the same front end, the same back end. OpenTelemetry is a plugin solution to that. If you use it during development, it can really help you with debugging. One of the big challenges with AI development, especially when working with large language models, is that most of them can't be run locally. So if it's a large model, you typically can't run it on your local machine, so you need to connect it to a live API. And this means that debugging can be hard because things are hard to reproduce. So the more information you can have in the system when you're developing, the more reliable you can make your application. So OpenTelemetry really helps with that because you can drop OpenTelemetry in your stack and you get full traces when you're running locally. And like I showed you with the .NET dashboard, the .NET dashboard gives you a local environment that looks like a production monitoring environment, but it just runs on your local machine. And then when you're finished, you can destroy that infrastructure and start from scratch. And then my last tip is to look for instrumentation libraries of the current technology stack. So if you're using a specific front-end framework, if you're using a specific database architecture, then look on the OpenTelemetry site to see what is supported and what instrumentation is available. Here's some resources to help you on that journey to plugging OpenTelemetry into your AI application. So here's the RAG sample app that I showed you and the documentation on how to set up OpenTelemetry support both with the .NET Aspire dashboard and with Azure Monitor. Here is a tutorial on configuring tracing with OpenTelemetry in PromptFlow and how to set up observability in a cloud-native .NET application with OpenTelemetry, with or without the .NET Aspire dashboard. And then finally, if you want to unlock the power of telemetry in the semantic kernel SDK, here's a great blog post I found that tells you just how to do that. Thank you so much for your time and enjoy the rest of Build.